Welcome to my channel Biochem by World. Today's topic is electrophoresis. Firstly, I'd like to dissect this word electrophoresis. It is made up of two words, electro and phoresis, where electro stands for the energy of electricity. That is the use of this electricity, and phoresis is a Greek verb which means to carry across. Basically, what is electrophoresis? Okay, this is the technique which is used to resolve a mixture of charged molecules. Okay, a charged molecules under the influence of electric field, where these charged molecules can be amino acid, okay, proteins, nucleic acids, that is DNA or RNA. Okay, and charged molecules in electric field move, or we can say migrate, at a speed which is determined by a ratio, that is charge to mass ratio. That is the speed of that charged molecule during this resolution using electric field depends on charge to mass ratio. Okay, according to the law of electrostatics, an ion having a charge Q under the influence of electric field will be facing an electric full force that is equals to QE, and during the migration the movement of this charged molecule will be opposed by a frictional force which is given by Vf, where the V is the rate of the migration and F is the frictional coefficient, which depends on shape, the size of the charged molecule, and the viscosity of the solvent or the medium which we are using for the separation. Okay, the frictional coefficient usually it is for a globular charged molecule is given by Stokes law and is equals to 6 pi eta r, where eta is the viscosity of the solvent and r is the radius of that globular shaped charged molecule. In a constant electric field, okay, these two forces are balanced and is equals to QVF. The rate of the migration of that charged molecule is usually expressed in the term of electrophoretic mobility, that is mu, and is given by the ratio of the migration rate to that of the electric field. Using equation 1, electrophoretic mobility can be expressed in this term, that is Q, the charge over divided by the frictional coefficient. This equation expresses that electrophoretic mobility, that is the rate of the migration of the charged molecule, depends upon these factors, that is it is directly proportional to the charge. More the charge more is the charge of that particular molecule, more is the rate of its migration. Okay, and electrophoretic mobility is inverse proportion with the size, the shape, and the viscosity of the solvent medium. It means that more is the size, lesser will be the speed of its migration. Globular the shape, more will be the rate of migration, and fibrous, if that charged molecule is in fibrous nature, then it will be having less electrophoretic mobility, whereas more is the viscosity of the medium which we are using for the separation, lesser is the electrophoretic mobility. Basically, electrophoresis is of two types: moving boundary electrophoresis and zone electrophoresis, where moving boundary electrophoresis is also termed as free electrophoresis. Moving boundary electrophoresis and zone electrophoresis. What is the difference between these two types of electrophoresis? Basically, there is one difference, that is moving boundary electrophoresis is having no supporting media. Okay, it occurs in a free solution, whereas in zone electrophoresis we are using a supporting media, that can be a paper or can be a gel electrophoresis, which is used very frequently in nowadays. Okay, what is moving boundary electrophoresis? Moving boundary electrophoresis, that is the separation of the charged molecule is done without the use of a supporting medium. That is, suppose this is apparatus, I put my mixture, okay, and here I pour a buffer, and I connect these two with electrodes, and when I apply an electric field, they resolve, the mixture of the charged molecules resolve and they move towards these electrodes, and they, according to the charge mass ratio, they form boundaries, they separate. Okay, whereas in zone electrophoresis, gel is used and the same happens, that is separation of molecules on basis of the charge to mass ratio. And what is the advantage of having supporting medias? Okay, the advantage of supporting media is that when there is no media, there is no supporting media, there is generation of heat. Okay, there is generation of heat in the buffer systems, and there is diffusion of the bands. Okay, diffusion of the boundaries of that resolved mixture. So using of the supporting media, this disadvantage is overcome, and there is a result of very sharp separation of the sharp bands of the resolved mixtures. Okay, thank you so much, and please like, subscribe my channel.